The next type of a nuclear reaction is nuclear fusion. Now, fusion, it's a process where lighter nuclei will combine to form a heavier nucleus, which is more stable than the lighter ones. This is basically fusion. Now, guys, fusion reaction, there's a lot to talk about fusion reaction, actually speaking. Okay, there is so much to talk about nuclear fusion. But let's restrict ourselves into what you have. Let's not talk about a lot of things. Now, in a nuclear fusion reaction, see, this is the mathematical formula or the mathematical equation. 4 hydrogen will combine to form helium, and it gives out different particles. Like you have a positron and you have a neutrino, and along with it you are going to have energy. Okay, now this is more like a general scenario, like a general equation. But to be honest, this reaction what you're seeing, it is actually split into 3 or 4 parts. Because first 2 hydrogen will combine to form, it won't make helium. Okay, it forms deuterium. Then 2 deuteriums will that will make a tritium, and it releases 1 more proton. So there are a lot of in-between steps. But at the end result, you're going to have helium, 2 positrons, and you're going to have a lot of energy. Okay. Now, first thing, for fusion to occur, it's a very important process. We have to create the temperature, because fusion occurs in the core of stars. Sun, for example. This is what I was telling. The energy what we receive is actually because of the fusion reaction. Nuclear fusion reaction. Okay. Now, what we do, we have to create that environment. You have to increase the temperature, increase the pressure. You have to increase it to such an extent that the Coulomb force of repulsion should no longer exist. That means the 2 hydrogen atoms, both are positive, right? They have to combine together. See, for them to combine together, they have to get rid of that Coulomb's force of repulsion. For that, we are creating this temperature. Okay. Once it overcomes that Coulomb barrier, they combine. And once they combine, they release the energy. It becomes self-sufficient. Like you don't have to provide energy anymore. It just keeps on liberating energy. This type of reaction is what we call as thermonuclear fusion reaction. Okay, thermonuclear fusion reaction. This is what happens in stars. Like sun, at this very instant of time, sun is converting hydrogen to helium. Probably few millions of tons of hydrogen is being converted into helium in sun. Alright. Now, what happens inside the sun, at the core of the sun? Already the temperature is so high. Why it is so high? Because of the fusion. So initially the gases will combine together and then they collide. It's a process. And once the fusion starts, it will automatically increase the temperature. And once the temperature increases, more hydrogen will start to combine, more energy, more. So this forms a self-sustainable chain reaction. Okay. So this is what happens in nuclear fusion. Fine. So these are the 2 types, fission and fusion. Understand the difference between fission and fusion. Okay. And what happens in fission and fusion.